All right, so now we'll do 2025 10B problem 8, the first in your rapid fire set for 12B, problem 6. Emmy says to Max, I ordered 36 Math Club sweatshirts today. Max asks, how much did each shirt cost? Emmy responds, I'll give you a hint. The total cost was this right here, but there's a decimal point here if you can't see it, where A and B are digits and A does not equal 0. Very clever, Emmy. So after a pause, Max says, that was a good price. Oh, okay, so Max is obviously somebody who knows number theory here. The question is, do you? So what is A plus B? The idea needs to be this. If you're looking for each shirt costs the same amount, obviously, right? So you're going to divide 36 into this number and it must go in equally. Do we care about the decimal point? Not really. We don't care. Just consider it as cents. It's all cents. Does that make sense? Okay. Now what we're going to do is this. Your digit sum is going to have to be a multiple of 9. And the last two digits are going to have to be a multiple of 4. So that's kind of the rules we're going with here. How do you know to pick 9 and 4? You pick two numbers or integers that are relatively prime whose product makes the larger number. So for example, if I wanted to know if 18, the divisors would be 9 and 2. If I wanted 24, it would be 8 and 3. So you can't have a common factor in either of the two numbers, and they must multiply to the larger number. 12 would be 4 and 3. Okay? So 36. So here we go. We've got 2 A's and 3 B's. If you got that in school, you'd probably get in trouble. But luckily here, we don't have to worry about that. So this needs to be equal to a multiple of 9. We also need BA to be a multiple of 4. This is just kind of like, here's how I did it. This is a multiple of 9, and this is a multiple of 3. The only way this is going to be a multiple of 9, which is a multiple of 3, is if I add a multiple of 3 to another multiple of 3. It doesn't matter what B is. This is a multiple of 3. If this is not a multiple of 3, you would never get a multiple of 9 because 9 is a multiple of 3. Okay? This is a theorem that you learn or a property that you learn in Intro to Number Theory. Again, new class starting the first week of December. If you'd like to try that class out, there's 6 spots left. So from here, we say what? This has to be 0, which is not allowed, 3, 6, or 9. So if I try 3, can A be 3? No, because it can't end in 3 and be a multiple of 4. So it's going to have to be 6 because it can't be 9 as well. So this is going to have to be 2 times 6, which is 12. So I've got 12 plus 3b. A multiple of 9. Why don't I make b interesting? 2. Why don't I make b 2? We'll try that out. So if I put 2 in here, I'll get 12 plus 6. Let's see if 2 would work. But the problem with 2 is it doesn't work with the BA. We can't have 26. So what else could we do? From 12 to 27, 25 is not going to make it there. How about to 36? B could be 8 now. The problem is 86 doesn't work either. A being 6, 2A plus 3B. Oh, did we really can't get 6 here? Okay, so we got 12. We can't add 6. We could not add 9. Could we add 12? That wouldn't be a multiple of 9. So we are going to need, let's see, 46 won't work. And then 56 could work. What about 56? Oh, that'll work. Yes. Oh, why did I think it wouldn't work? I was thinking 25. So yeah, 25. This will be 15. So yeah, here we got 2 times 6 plus 3 times 5. There we go, great. 12 and 15 is 27. And these things happen when you're live solving too. If you make little errors like that, it's normal. Don't be too hard on yourself. Your brain doesn't always work in perfect, action and thought processes. So here we go. Then this now makes this 56, which is a multiple of 4. It's 4 times 14. So at this point, we have the values, and a plus b will be 6 plus 5. It will be c, 11. Let's get to the next one. So it's about 7:10 a.m. right now. I am going to try and finish these before I go to sleep, meaning the 7 through 10 rapid fire for the AMC 12B. What is the value of this? For starters, probably should do something with this. We can't really do something with the summation within a log, but because of this n, we could maybe make it into a combined fraction. So that's what I did. First, I made it log base 2 of n plus 1 over n. Basically, you make this n over n and you add, and now that is a quotient within a log, which means by log rules, it's going to become log base 2 of n plus 1 minus log base 2 of n. You take the upper one, it goes here, the lower one goes there. The mnemonic device is that the division sign becomes the minus sign. So now when you look at what you have, log base 2, and I'm going to put this as n plus 1 times log base 2 of n. At this point, I went ahead and switched this to become a, that to become b, and then a times b like this. Then I said, what's a over a times b? It's 1 over b. And then I'm minusing, you're basically doing this, a over a times b minus b over a times b. So cancel the a's, cancel the b's, minus 1 over a. And at this point, you're going to have log base 2 of n plus 1. No, hold on. It's 1 over b first. So my b is log base 2 of n. So it's 1 over log base 2 of n minus 1 over log base 2 of n plus 1. So now, at this point, we'll start plugging stuff in because this is still our summation of this entire expression. So we're just going to plug in 2. You probably get some kind of telescoping action going on here. So you're going to get, I'm just going to write it over here so I have more space. Maybe up here. I don't know. We'll just do it here, yes. You're going to have 1 over log base 2 of 2 minus 1 over log base 2 of 3 plus, now you're going to let the k become 3 and you're going to plug 3 in. So it's plus 1 over log base 2 of 3 minus 1 over log base 2 of 4. As you can see, because this was a minus that term and that's the plus, we are exactly going to get that telescoping action. So you will keep this in the front, it will be 1, and your very last term will be when you put 255 in, and it goes right here. So you're going to have 1 minus 1 over log base 2 of 256. Now, 2 to the 8th is 256, so this is going to become 1 minus 1 over 8, 7 over 8. Answer choice C. Let's get to problem 8. All right, next problem in this rapid fire is problem number 8. If you were in, and those of you who were in my Sunday AMC Fundamentals 2, we used the Volume 2 textbook, we took an excursion over to this exact concept in a pre-calc textbook, and we practiced it. We practiced going fast at it as well. We practiced the speed for it. So I hope those of you who were in that class got a little edge on this problem. There are integers a and b such that the polynomial x cubed minus 5x squared plus ax plus b has 4 plus rad 5 as a root. You can make a quadratic first with this root, and since those are integers, you're going to know that your quadratic is going to have integer coefficients. which means if 4 plus rad 5 is a root, 4 minus rad 5 is a root. And to build the quadratic, you're going to add those, and you're going to write x squared minus 8x plus b, or plus the product of them, which is 16 minus 5, which is 11. All we're using here is Vieta's sum and difference formulas, that is, but we're using it kind of in reverse. For a quadratic, the sum of your roots is negative b over a. But if you assume that a is 1, which is what we're doing, we're assuming that it's 1, and it's fine. It is going to end up being 1 because we don't have a 1 anything in front of the x cubed over here. So you just assume that a is 1, then the sum of the roots just becomes negative b. And since it's negative b, we write negative 8. And then the product of the roots is just going to be c over a, but again, we're letting a equal 1, which is what I taught you guys to do. So you're going to have 16 minus 5 is going to be 11. Then this also has to have a sum of roots with this one, which will be positive 5. And even in the small notebook class, we covered Vieta's quite a bit. You should have had an edge on this problem also just from doing the Vieta's rules and how they work for cubics. So if the sum is negative 5 and these two sum to 8, we must have to add a 3 to that. So the other root must be negative 3. So that 4 plus 4 is 8 minus 3 gives 5. Negative 5 is what you write here because it's the negative sum. The negative b over a, or you can say negative second coefficient over leading coefficient. So from here, the other term must be x plus 3, because if negative 3 is a root, it's x minus the root. So x minus negative 3 is x plus 3. All you have to do now is distribute, and you're really only looking for ax plus b. So I'm going to do x times 11, which is 11x. 3 times negative x is negative 24x. And 3 times 11 is plus 33. Those are the only things that will affect ax plus b. So you're going to have negative 13x plus 33. The negative 13 and 33 are your a and b. You're going to add them. You're going to get C20. And you're also going to be very, very happy with your speed. Let's get to problem 9. Okay, this problem is problem number 9 from the 12B. What is the 2025 12B? What is the tens digit of this? Again, in the small notebook class, we covered it based on an old AMC question back from around 2005. They had this and they told you what it meant. They said it's equal to this, or actually that one had multiple 2's. I'm thinking of volume 1 textbook has this in it, but we covered this in the small notebook class. It was specifically concept number, let's find it really quick so we can snag it and have it ready here. It was concept number 99. We didn't actually maybe get to that one in all the classes. We might have got to it in several of them. It's right there. Okay, so yes, we have that concept. What is the digit of this? The tens digit of that. So in order to do this, you're going to have to group these. That's what that concept shows. Those get grouped. And so we're going to have 6 to the 6th. I'm going to make that 216 squared. 6 to the 3rd being 216. So I'm going to have 6 to this power. It's at this point that I'm probably thinking I'm looking for a pattern in the tens digit among the 6's. So I'm going to go ahead and make a list. 6 to the 1st is going to be 06. We are looking for tens digit, not units digit. 6 squared is 36. 6 to the 3rd is 216. But you're going to notice by number theory that we don't care about this 2 anymore. We only care about the last 2 digits. So 6 to the 4th is going to end in 96. 6 to the 5th is going to give 540. and 36, which is going to be 76. All I'm doing is 6 times 90 plus 6, 540 and 36. Then we're going to do this 76 times it as well. We don't care about the hundreds digit. We're ignoring it because it has no impact on the tens digit. So 6 times 70 plus 6 is going to be 420 plus 36, and that means 20 plus 36 is 56. 6 to the 6th is 56. When you do 6 times 50, you get 300 plus 36. When you distribute there, 336 is going to be 36, and 6 to the 7th will end in 36. So as you can see, we've got a repeat now because this and this are duplicated. And so as a result, you're going to have a pattern that goes 0, 3, 1, 9, 7. And then it's going to start at 5. And you say, well, 0 and 5 are not the same. You're correct. Only the first one will have the 0. Every other group of 5 after this will start with 5. Be very careful with that. Originally, I looked at 31975, 31975, and I thought, that's kind of risky. Can I just start at the 0? And I checked it, and it works out just fine. So 03197 is your repeated cycle of 5. And so all you have to do is find what is this number mod 5. In other words, when I divide it by 5, what is my remainder? You can actually take the two numbers here and mod them out individually. This becomes 1, this becomes 1. This number is congruent to 1 mod 5, which means you're going to be at the first term of your cycle, but it's not 0, it's 5 for every cycle after the first, and that's why the answer is C, 5. We'll get to problem 10. Okay, and this was one of the most interesting problems on this year's test. It was a kind of a lot of fun, depending on your definition of fun or your connotation for it. It's 2025 10B problem 13, 12B problem 10. The altitude to the hypotenuse of a 30, 60, 90 triangle, right triangle, is divided into two segments of length x less than y by the median to the shortest side of the triangle. What is the ratio of x over x plus y? So what I'm going to do is I'm going to draw, let's try to draw it straight on like this. And we will claim at least that this is 60, and this is 30, and this is 90. Okay. And we're going to draw the altitude right over to here. And we're also going to draw the median right over to here. I guess approximately the median. Okay, and this looks like the shorter piece over here. We could call this x and we could call this y. I'm going to label them as A and B, where A is X and B is Y, for reasons we'll get to in a moment. So yeah, what do we do here? We got X less than Y, A less than B. We can't be 100% sure yet at this point in the problem, by the way, that that is the smaller piece. You might go back to, if you had my small notebook black class, you might be thinking about secoi, which is the centroid, circumcenter, orthocenter, and incenter. And you think, well, but this is a median. But does a median cut an angle in half? No, it doesn't cut the angle in half. You'd like it. Maybe you think that'd be good to get an angle. No, not what happens. And you think, well, should I add another median? Because the midpoint of the hypotenuse, then I could get the 2-to-1 ratio that medians create. Well, centroids create at their centroid. And so you think about that. There's a lot of different things you can do here. It's almost, there's a lot to think about, right? And so you go, all right, well, what can I just add more information? I'm going to add 30 degrees here. And the reason that we're going to add 30 right there is because that's 60 and that's 90 by virtue of it being an altitude. Okay, then what? And you say, well, really don't know. What if I labeled these two pieces? It's a midpoint, right? If they said median, that means it goes from a vertex to a midpoint. Why don't I give these some lengths? I'll call this 1, and I will call this 1. And so now you're going to have 1 and 1, and that's 2. Your side opposite 30 becomes 1. What do we get over here? 60 is going to be 2 rad 3. And then you know that your hypotenuse is 4, so this part up here is 3, meaning from, if I give this A, B, C, it'd be from A to D would be 3, right? And you go again, is there some property? You really want there to be a property for altitudes and medians, and maybe there actually is one, by the way. It could be like, Euler's line type thing where you get the centroid, circumcenter, and orthocenter relationship. But you kind of try some things out. You're like, okay, I've got 90 degrees here, and I know this is 3. I even went so far as to try, I'll write this piece right here in terms of a and 3. It'd be like, right, it'd be the square root of a squared plus 9. And if I do that, we also know, by the way, that BD is equal to root 3 because you have a 1 to 2 and root 3 ratio. This is the side opposite 60. So you know what x plus y is right here. It's going to be root 3. We just don't know what x is, or a in the case that we wrote here. And so you might have gone, and this is a great thought, by the way. There's nothing wrong with this thought. You might have said, I have a Cevian, or a Chavian as they're probably called properly. I say Cevian all the time, but I'm sure that's not how you say it. Chava, I think, is the way you say his name. But this line right here, you could use Stewart's theorem. And so Stewart's theorem, you could say, well, this squared, which would be that, times the whole thing, root 3. So you could do like a squared plus 9 times root 3. And then you'll have the two pieces, which would be, you could call it a and root 3 minus a. And that would be this piece times the whole, which is root 3, and equals, and you could do 3 squared times b and 12 times a, which is 2 rad 3 squared. The problem is when you do that, it's a dead end. What you get is 0 equals 0 in essence. And so you kind of are like, well, what else do you got? Any other bright ideas? And sometimes this is where you have to say, what if I'm looking for this point of intersection. What if I put this as a coordinate plane? And we call this, in comp math, it's called chord bashing. So if you can't find some nifty similar triangles type thing, and you might have hoped right here with these two vertical angles that you would get similar triangles, but you don't. That angle's not 30, this one is, so not going to work out in your favor. And yeah, you don't have like alternate interior or anything like that. So instead, we're going to chord bash. You're going to turn B into the origin, and A is going to be your y-intercept. And you're going to go down to root 3 and over 1. And oh, really quick point, by the way. They didn't tell us any lengths. Guess what that means? You can make them up. It's going to be the same for all lengths that you would choose as long as you obey all the rules of the problem. So if somebody else put, 1 for the whole side, root 3, they'll get the same answer. It's just that our algebra will look slightly different. So this line going down here, the median, I'm going to erase the Stewart's theorem nonsense because it doesn't work out. You're going to have y equals negative 2 root 3x. And this part here, how am I going to get the slope of this line through the origin? And again, they say that you don't have to know trig, and you don't, but you can say, by the way, that the slope of any line with the horizontal, if I call this theta, which is an angle, then the slope of line L is going to equal tangent of theta. So if you thought of that, and you don't have to use tangent here, by the way, you can do something else, which I'll do in a moment. But if you knew that, tangent of 30 is the sine of 30 over the cos of 30, which is 1/2 over root 3 over 2, and the 2's cancel, and you get 1 over root 3, and that would be your slope. And so you're going to get, oh, this is plus 2 root 3 for your y-intercept of a, because you're up 2 root 3. Your other equation is y equals 1 over root 3x. Now, let's say you didn't learn the unit circle and you're not expecting to have to use it. So you didn't really think about the tangent idea or didn't know that one. Are you out of luck? No. Just drop a height from right here and you have 90 degrees. And therefore you have 30. And you know opposite 30 is a 1 to root 3 ratio. So your rise is 1, your run is root 3. You don't really care what this length is. Don't look at this 1. It's not this 1. It's the generic 30, 60, 90 proposition that, you're looking like this. So this is 60. This is going to be x root 3, and 2x. We always want nice, simple concepts to be the things that we use. We've known 30, 60, 90 since 5th grade, 6th grade, 7th grade. This is something that was accessible. You're just not seeing that when you look at it. So now you drop it down. Your rise over your run is x over x root 3, 1 over root 3. What do we do now? Well, if I can find the distance going this way, which is going to be my x value, this is x comma y. My x value is my distance from my y-axis, also a small notebook concept. And if I can find that, then I can use it to help myself get the B answer over here. So what we'll do is we'll use 30, 60, 90 relationships at that point. So what I'm going to do is set these equal to each other. So 1 over rad 3x equals negative 2 rad 3x plus 2 rad 3. You're going to multiply by rad 3. X equals negative 6x plus 6. You're going to add negative 6x. You're going to get 7x equals 6. And x equals 6 over 7. Now the x coordinate being 6/7, it is opposite 60 degrees. This right here is 6/7. I'm going to go ahead and put it on this one just because that picture's kind of cloudy over there. This is going to be 6/7. We have to divide by rad 3, which is going to give us 2 rad 3 over 7. Divide by rad 3 to get the side opposite 30. And you double that, where this will become 4 rad 3 over 7. So that is the B value right here. Keep in mind, we're looking for A, which will be rad 3 minus what you just found, 4 rad 3 over 7. So at this point, you should see that all of your rad 3's are going to cancel. This does not become 0. It becomes 1. So you're going to have 1 minus 4/7 all over 1, which we don't care about the 1. And 1 minus 4/7 is going to be 3/7. Really great problem again. Chord bashing, never forget it. If you did take my small notebook class, we went over that exact thing with the centroid problem where we looked at the concept about it being the average of the coordinates. So, when should you chord bash? It's simple. If you can't find another way, you should consider chord bashing. It's kind of a safety net. Any geo problem can be turned into a chord bash problem. You just don't always want to do that. And it takes a little bit of intuition to figure out when you should. And I don't even know, is there a better way with similar? I don't know. This is the way that I solved it. If you had another way, feel free to drop a comment down below. Let's get to the next problem.